It's such a great thing. You burn less gas, you can pay attention to not maintaining your speed, but like to the idiots around you and all kinds of good stuff. So maybe I'm not the only one, but we don't share it from you. So anyway, yeah, so I drove from Marysville to here, anywhere between like 30 and 70.
30 and 70. It's a
you know, you have
gap.
that thought, like they're on a cell phone and other.
It's talking about kilometers per hour, right?
It's the random braking. So like that was terrible. Exactly. No.
Yeah, that kind of thing. Or around curves. Coming up to the campus, like, oh no, gentle curve. Everyone's going to slow down here as they do. So anyway, I got to recover because that was an hour and a half of hell.
Did you not ride your bike today?
I didn't. Yeah, so often on Tuesday and Thursday I'll motorcycle in, but the smoke I don't want to. It's still kind of smoky out. So
I made you just put a base mat down.
I'll be motorcycling.
He's going to pedal all the way here. Little bicycle.
All right, so I need to call roll. So if I could get you to not talk over the top of me for this. Okay, so what's going to happen is if you don't say you're here, I'm going to immediately drop you right now. Because someone's going to happen to me. So you didn't call my name. It's like, well, how many ways do I got to go about that? Abdullah Aziz. Brian Brooks. Here. Jacob Carlson. Kevin Crawford. Here. Colton Davies. Maddie Gideon. Is it Gideon? Yeah. Andrea Granada.
Yeah.
Am I saying your name right?
Andrea, yeah, you have it.
April Brown. Chris Henderson. Here. Jerry Lehman here. Hunter Lufkin. Richard Maltby. Here. Ethan Marshburn. Andrew Matley. Right here. Matthew Mazzocco. Here. Andrew Moskowitz. Here. Juan Carlos. Here. Denzel Peters.
Here.
Miguel Rosales. And Tim Porter. Does anyone add it? That's the roster as I have it this morning. Although I guess I can drop two. And one of them's in another class, so maybe we'll turn it. Yeah, so if you've seen me have encounters with people before, I don't like talking over the top of people, so usually I'll end up yelling at somebody about that and just say, if you're not interested in what we're talking about, that's great, but you don't need to be here for that. Be disinterested elsewhere, so that if there's one person who is, they don't have to try to filter your voices from mine and that kind of stuff. Is all I ask, which is another way of saying just let's treat each other with the respect that human beings deserve. So if I don't give a shit what someone's saying, I will walk away from them. That's what I do, which is what I prefer that you guys do. It doesn't hurt my feelings, but I don't like it when it makes it hard for me to do the job. So that's all. All right, sorry, question.
I apologize. I came in late, but I am here. Jacob Carlson.
I noticed the parking is real bad today.
Yeah, I didn't anticipate that.
And the buses don't go. I know that as well. All right, so there's a good chance it's true that if you look at the first exercise, and I may not have communicated clearly how those work. You just do them or you don't do them. I'm here during the lab time to help you with them and give you feedback about your work on them, but that's it. You don't submit them to me. If I were you, I would save them. It's part of your portfolio as you do them. Plus, I promise you that there's stuff in there that you will want as reference material when you get to doing the projects, which are the things that you do turn in. So I don't I try not to waste your time too much with stuff that you're not going to use somewhere. So if I'm asking you to use it and I'm giving you examples of it, there's a good chance it's going to have, I hope, have some value later on. So anyway, but I'm still getting questions about what do we do when we're done with it, and I say you do something else. Is what you do. Yeah, toy around with it, or work on another one, which some people were doing in yesterday's class, or start to work on the project and see if you can figure any of that out, or do something else. So the only thing I ask, of course, is that if it's a distraction from the work that the rest of us are trying to do, that we take it elsewhere. Okay, so let's see if you can beat yesterday's class, because I had to beat questions out of them. And that's really how I prefer things to go. And I can try to help you sort of hack the problem, as it were, because I think a lot of people will just say, well, I don't have the words to ask. I know I don't know what the hell's going on, but I don't know what to ask. So let me show you how I would go about hacking that problem, and then you can decide if that's useful or not. Now, if you do have questions, then as this is firing up, I'll queue up the questions. So does anyone have? And what I'm going to do is organize the class today around the first exercises, and try to get you to a point where during lab you can complete them if you choose to do that. So, are there any questions that immediately come to mind? My main goal is to give you a sense of how my projects and exercises work, what you're supposed to do with all that material and how they work. And then hopefully you won't lose complete sight of the fact that there's actually some C++ stuff in there as well. So the C++ stuff is this stuff, and then you have sort of the meta, which is learning how to work with my materials in this class. I will tell you that programming is a lot of fun, and C++ programming is not, which is unfortunate for a while. At a point, you get used to all the mess with C++ syntax, and then you can have fun again. But it is fun, and by fun, I don't mean haha, jumping around in constants or kinds of fun. Although not everyone will find that fun either. But what I mean is intellectually engaging, which is how most people end up at the press. Most people define fun by my mind was like lit up the whole time, and I was engaged in the fun. I think it was like who was in here before? Did they not turn this on? They didn't. All right, so now we're going to wait for this to play up. So there were some hints. All right, so while we're waiting for me to fire up, what is this? Standard template library. So you know what a library is, hopefully, which is code that other people wrote that is supposed to make life easier for us. How do you get libraries into your code? Includes. All right, so probably if there's an STL something, there's also an include. A library something, there's probably at least one include to gain access to it. When you use your CM reader? Yeah, when you've done that before, that was a library as well. Standard? Standard means that it is standardized, meaning that everybody who implements a version of it, creates a version, abides by a predefined set of functions and other things, if that makes sense. So if you go create an STL thing and I go create an STL thing, they should look virtually the same. The inner details might be slightly different, but the functions should look the same because they're standardized. It also means that any standard C++ installation should have these libraries in them. So if they work here in a C++, they should go somewhere else where there's a C++ and still work. What's the template part? That's the hard part, actually. Say again? Okay, well that's true. So the library has classes. What does it mean that a class is template? There's a template class. Any data type can go in it. So they are sort of type agnostic is what I would call them. They're data structures that you can create and associate with any type that you want. Let me give you an example of a non-STL data structure. Sort of. But this array numbers will always and only ever be what kind of data? Integers. That's not the best example. We'll see that for a second. One reason to go do the reading is so that you're kind of armed with this information up front, but also it's because you will learn your way around some of these reference websites that will make your life way better in the future. My big growth moment when I was in graduate school was when I realized that this existed, because no one had ever told me anything about the standard template library. And then I was just sort of doing whatever I did. There wasn't a whole lot of websites for this stuff in those days, but somewhere in some book somewhere I saw this thing on that thing. And then I'm like, holy crap, there's all these things that I could have been using all this time, which I could have spent way more time on the hard stuff and way less time on where does the data go. It was quite the revelation. So now I try to share that with people so that you know about it, because it's empowering. What you want to do is spend your brain power on the interesting parts and not the dull parts. At least that's what I hope that you want to do. Then you might guess, what is the standard array? I mean, why are these here together? So the STL is data structures or containers. Standardized data structures are containers that are data type agnostic. So since these are here together, what would you think might be true about array?
They follow the standard.
It's one of those containers, and you do. A standard array is one of those containers that is in the standard template library. So my way of introducing you to the standard template library is to introduce you to the standard template library array class. It is very much like this kind of array, but it has other goodies that come with it because it's from a library and not just a language feature. This is a language feature. Oh, and by the way, you can just do this. Just Google it, C++ STL. And then pick any damn link that you want to. I'll just pick the first one. Google's gotten pretty good at this. I'm giving you a relevant one right up front. Anyway, this is on the topics for the week. So if you had looked at the topics for the week and either followed my link or thought, well, I'm going to go find my own STL documentation, you might have found your way to this. A set of C++ template classes, and they all have a particular look to them. So we're going to see one today, and then you'll begin to recognize when you see them in code, oh, that's a template. I know where the template is. In other languages, they call these generics. In Java, they're called generic classes. In C++, they're called template classes. They're kind of, I created this thing, and I don't give a shit what you put in it. Whatever you want, I don't care, which is nice. Whereas when I created this one, I just took away all your options, basically. Put integers in here, that's it. All right, so just to show you, here's the container. Here's a list of the containers. You don't need to look into this right now, but there's a lot of different containers. And the reason I'm showing you that there's a lot of them is because they are standardized to a certain extent. If you learn one container, there's a good chance that you already know a lot about the other containers just by their nature. So we're going to use the array. We will at some point use queues and stacks, and hopefully maps. That was the thing that I discovered. I'm like, wow, this is awesome. It's actually totally amazing. So anyway, if you learn arrays, that should mean that you know the basics of using most of the rest of these things, even though they're all slightly different in terms of what they're meant to be used for. You actually already know an SPL structure, by the way. You know this one. You may not have known it, but strings are standard template library compliant, meaning that they sort of follow the same standardized set of functions. And I'll just give you an example of that. How do I know how many characters are in S?
Dot length.
Say again?
Dot length.
Dot length, and there's another one, that's sort of a string particular one, and then there's a synonym for length size. So string has size because it's trying to comply with the standard template library way of doing things. Now I'm telling you that because then I can turn around and do this. Oh, by the way, okay, so keep that in mind. Dot size is how I know how many characters are in an STL compliant string. This numbers, does it know anything about itself? Like, does it know its size? Correct, does it?
It does know that.
It doesn't. Is there a way for me to ask numbers itself, how big are you?
Numbers dot size.
It doesn't. It just doesn't. Who has to keep track of that?
The writer.
You do. The person who creates this sort of language feature array has to keep track of how big it was. Often we do something like this. You've seen something like that where you sort of have a second variable that sort of makes it convenient to keep track and code of how big the thing is. So it doesn't, as it turns out, know how big it is. But in the standard template library, I can create an array of integers of size 5. I'm just going to call it nums because I ran out of space. So this is what template classes look like. They're usually the name of the container, the array, followed by some brackets and some data inside of it. Now arrays are a little bit unique because they need to know what goes in them and how big they are. But now that I have this, can I get how many items are inside of nums?
Yeah.
Yes, I can. This time how?
Dot size.
Dot size. It's a function. So you have to put the parentheses because it's a function call on nums. So numbers, which is very similar in terms of its limitations and what it's used for, does not have this sort of extra capability. And these standard template library ones have additional capabilities on top of that. So for example, you can plug them into pre-written sorting routines that will sort them for you, among other things that they will do. But that's one that you're going to see in code. So the standard template library array is really just an enhanced array with extra functionality connected to it. We should remind ourselves before we get too far into this, while we're on this topic, by the way, how do I make this array bigger? I can't. It's an array. Once it's had its size, you're done.
At least in C++.
Yes. So arrays in C++, once they're sized, how do I make it smaller? You can't. It's 5. It will always be 5 unless I recompile the code with a different value. So standard template libraries are very similar in terms of the way that they work. So if you had to guess, can I change the size of this array? No, it is 5. I can't make it bigger and I can't make it smaller, just like the built-in arrays. But it still, don't forget, sort of has some extra goodies that make life interesting. How do I access individual elements of this array? Like, how do I access the first element?
Bracket 0.
What is it? Brackets. Remember that one? So how would I access the first one of this one? You can't do that. Or you could also do
Same way.
brackets. So I don't get low on the screen. So the standard template library array actually has an additional option for accessing elements in it. So this is nums, the array, dot at, and then the index value. And this is nums square brackets, the index value, those are the same thing. They're exactly the same thing. You can use either one if you want. Can that index value be zero? I mean negative?
No.
No. What's the biggest value for both that it could be?
4.
4. So I think it takes a long time for some of us. I'm sure I was one of those to sort of get it in my head. People tend to sort of, instead of thinking of how big they want the array, like I need to store 10 numbers, they think instead, what's the size of the biggest index I want, which doesn't make any damn sense. But that's how some of our minds like to work the problem. So remember, the first thing you do with an array is you decide how big it's going to be. Second is the problem of, okay, now what are the good index values for that array? So if I have a size 10, the smallest array, the first element rather is 0, and the last element is 9. Another way to say that, by the way, what's a way to use this to express the last index? -1. That's the last index, which you can use in code. All right, so that's my quick refresher, and I started there because that's, if this were the second week, then you would have already done an exercise in my class, and we wouldn't have to spend time on that. The point of the exercise is to introduce you to the STL, and specifically the array that's from the STL, to begin to familiarize you with those tools because they are useful. But because it's the first week, now we're going to spend a fair amount of time just talking about how do I put my exercises together and how do you work with them. Yeah.
So what you're saying is exercise 1 is for the second week that we do, or you want us to have done exercise 2 so that's during the week?
Now, so if I were in your chair, I would sort of endeavor to, like before I sort of called my week done, I would hope to finish the exercise for that week. So exercise 1 for this week is what sort of my goal would be. Once we sort of get a little bit of momentum going, then what I hope you will do is sort of spend some time in lab working the exercise until you feel like, okay, I'm going to get this, no problem. And then some other time working on a project that's the next nearest one, so that you can get assistance with those things. But I'm just saying for this first week, we're about to spend a fair amount of class time on just how the exercise is going to work, so that when you get to exercise 2 next week, you just don't have to spend as much time just figuring out whether all these damn files get them supposed to do it. Where did this go, by the way? I put that link. It's there. By the way, just let me show you. I've noticed some of you are already doing this, so that's good. So let me click on this standard array link. It should go to this. All right, so this site right here, the C++.com site. If it were me, if you were asking me my advice about such things, I would say go here early and often and get comfortable with its format and reading how it presents material, because they've got everything, just everything. It's about as good as it gets for C++ documentation. So this is the array. It tells you that it's a template class. There's some stuff, what I tend to do when I'm reading documentation, I just kind of go past the stuff that I can't make any sense of yet. So if you don't know what all this stuff is, just don't let it hold you up, just move to the next thing. And then kind of just quickly read. You actually know what this is, a fixed size sequence container. That's sort of the beauty of arrays, they're fixed size, and they are in memory in the sequence, which is why they perform so well. But if you scroll down, you'll find all of the things that arrays can do. So if it's in this list, it means that you can have an array like nums and say dot begin, parentheses, right? Or dot size, parentheses. Or dot max size, parentheses, or dot empty, parentheses, and so on. Does everyone get the idea? The other thing you can do, though, there's the square brackets operator, and the at operator, and some other, but let's just look at size so you can see how these pages work real quick. So it returns the number of elements in the array container. That doesn't mean sort of it's keeping count of how many items I've like written code to place in there. Once you create an array, it's got 5 integers in it. It just does. But if you scroll down, most of these pages will have examples. That's something that I think is super, super useful. You read a little bit and then you scroll down and you see examples of how they're using it, which I think that was just luck that theirs was size 5 also. Right, but anyway, just so you know, that's there, and my hope is that sooner than later you will bring that up and begin to use it as a reference. Doesn't mean you can't ask questions and can't ask for help, but you will feel powerful if you can find things for yourself in here and just use them. We'll do this. Right, so what time is it? All right, I spent a half hour on that. Let's see how long it takes to do this rest of this stuff. Right. So I'm going to exercise 1, and I'll give you a chance to ask me, but my plan is to kind of go through an example of how to get started on it. But you can ask if you have questions, and if I know I'm going to address it at some point, then I'll just sort of write it down and come back to it, or if I can address it right this second, we will. So I remember that I had a question which is if I don't know the words to ask a question, what should I do? So my hack is to just read back the shit on the page, right? So if someone gave me this and I'm like, what are the starter and helper files? What are the? What is the? How do I, right? I mean, literally, there's no harm in doing it that way. If you don't know the words, just steal them. They're right here on the page. Tell us about the class header, or tell me about catch 2, those kinds of things. So don't tell yourself, I don't know how to ask the question, because there's a page here in front of us with words on it, and you can just sort of fit them into a question. I don't have a clue what blank is, that kind of stuff. By the way, when people graduate from here and they go out into the world, I usually tell them to, in my opinion, you should keep 2 things in mind. One is be confident about your ability to learn new things, because that's one thing you demonstrate in getting through these classes, that you can learn new and difficult things, which is the best skill in the world to have by far. Way better than programming. It's just when you're learning new things, it's difficult to learn. Yes, you can. The other thing is to be humble enough to ask for help when you need it. It's stupid to sit there and not know what the hell's going on and never ask anybody, because you're not going to eventually just figure it out and catch up. What's going to happen is everyone else is going to leave you behind. And we know that, by the way, when kids start grammar school and they're a little bit behind, what tends to happen is that they get further behind. So you can fix that by just asking. And the other thing you will do when you ask a question is save someone else's ass, because they're sitting there being too shy to ask the question for themselves. So I've never not had it happen that other people in the room, I can see their reaction when a question is asked, like, oh my God, because they were being shy about asking. All right, so if there aren't any questions, so is it fair for me to assume that everyone just knows what's going on and has already done this? Right? So that's sort of what you're communicating to me. So the better thing to do would be to say, I don't know what the hell blank is.
I've never made file before you showed it.
Okay. So Makefile is a good one to look at. It's actually probably the best place to start, is the Makefile. Yes?
Yeah, I had a question on the Makefile too, because I was trying to, when we pulled up the command prompt, I tried to recreate that home, and I couldn't get through, like, as far as how you got through on.
Okay. Yeah, and we'll practice it a whole bunch, so
Okay.
it'll just be second nature. All right, so the Makefile. One thing to make note of about the Makefile is not C++ code and it is not C++ programming. What this thing does is take the complex problem of managing a project and how to compile its bits and pieces, make that as easy as possible. So this is a tool that programmers use, not just for C++, but for other languages, to manage a complex software project. So what is inside of it is a whole bunch of commands for compiling the various files that are part of your project. That's what it does. It's supposed to simplify that problem by letting you sort of program in the commands that you need once, and then you don't have to think about it again. But let's go further with that. So I'm going to go ahead and do my setup here, which means I'm going to create a folder on the desktop. I'm going to call it EX1. I put it on the desktop, hopefully for obvious reasons, it's easier to find there. And if I want to email it to myself, then I'll just zip it and email it off the desktop. Can I do this fast, or do people want to see this part?
Kind of want to see it.
Okay.
Because I'm going to need to find it.
All right, so I left the window open initially just so we can see the files go in there. I can see the files go in there as a. So right click is way better than, if you click on one of these links, it just gives you the raw source. And then you gotta copy and paste all that into a file and then save it. It's way faster to just right click, save link as. It already knows the name it's supposed to be. And I almost forgot to navigate to the desktop. So desktop, EX1, save that, and then it'll appear in my window. So there's one, save link as, there's another. Patch, save link as. File number 3, unit test, save link as, file number 4, and then the make file, which I know is going to want to put a .txt on there. I don't want that, but I'm going to let it happen and then go fix it after the fact. Stupid Windows.
That's like you said, like the most important one.
Yeah, because it's the one that I'm using to handle all my compiling work for me. But anyway, it's going to come in here with makefile.txt, and I'm going to right click it to rename it and knock the .txt off. I'm going to write down the files that I have. This is the same routine that you will use next week. At least that's what I would do. I'd create a folder for exercise 2, and then download the starter files into that folder, and then take the next steps. Yeah.
My make file came as a text document as well, but it wasn't .txt, so I can't delete the .txt.
Okay, then we're good.
I'm just good.
Yeah, as long as it doesn't have .txt on the end of it, then we're good.
But it still is a text file or a text document.
Yeah.
All right.
Mine actually just says file.
Yeah.
All right, so here's the files that I have. And you should ask as I'm writing this if you see something you don't recognize, because I bet a lot of you don't know something there. Maybe 2 things.
None of that.
All right, so what is Catch? So Catch is a library. It's not mine, it's written by someone else, but I use it to create these little software tests so that you can see if your code's working correctly. So that's part of it. What else? There's something else that most of you should be
HPP.
.hpp, so what is that?
Okay.
Yeah. Right, so have you seen a .h and a .cpp file? So .hpp takes both of those parts and puts them into one file. So when you see .hpp, that's what that usually means, is that the .h part and the .cpp part are all in one file. So there should be a follow-up question. Why would you do that? Why would someone put both of those pieces in one place like that? Usually people do it when it's relatively small and they want to make it easy to distribute. So the person who created Catch wanted it to be convenient for people to use the thing they created, so they put everything in one file. So now when I want to use it, I just get the one file and I'm ready to go, as opposed to having a whole bunch of separate files that I have to deal with. Am I relatively small, by the way? It's 13,000 lines or so, which is not much in the world of programming, really. I'll talk more about unit tests here in a bit, but that's always going to be there on the exercises because it's how I write the testing code that you can use to confirm that your code is working correctly. What else do I have? I have the make file. which we'll start with, but that contains all of the compiler commands that I will use for the code that is this project. I'm going to write the shopping list. The next one in my folder, shopping list.cpp. What is that?
That's similar to HPP.
No. Well, it shares one thing in there. Go ahead.
It's
Okay, yes, that's good. So this is my style. I'm not the only one who uses it, but my way of doing things, when I create a class, I usually create it in 2 files. If you use SandReader, you've seen this before. So what's the name of the class? Shopping list. And you don't have to do this in C++, as it turns out. I could have called it void shoe, and it could have shopping list in it. But that's deranged, so I don't do that. So what I do is I name it the same as the class. The .cpp part is the implementations. So that's the function definitions for the shopping list class. In my folder, I also have shopping list.h, which is what?
The class header?
It's the headers for the shopping list class. So that's the declaration of the class and the declaration of its functions, which we usually just call a header class.
So,
Yeah.
if you combine them for text, why didn't you just do that for shopping?
Well, I want you to have the experience of sort of seeing. I didn't combine this, the author did.
Okay.
So I just started taking advantage of the opportunity to show you in one place actually the way I would do it, and the way this person chose to do it in the extra. Yeah.
I was gonna say that, I think it's the reason why we're gonna do these big projects. It's easier to find the section that you're looking for, if you have a file and you can go back. Instead of scrolling over all of it.
Yeah.
That's the.
There's also you can actually pre-compile the implementations and put those into binary library code, and then just ship the compiled implementations and the source headers. So you can kind of hide the work, as it were. What's my other one? Oh, unittest.cpp. My other file is unittest.cpp. So notice it's different. In my naming convention, if it's not a class, I won't generally capitalize it, camel case it, but you can probably have a sense of what's in here. Some kind of test. What particular kind of test? There's a thing to know. Unit test. So who knows what a unit test is? No one does. A unit test is a test of a unit, but what a unit test really means is that we're usually separating out one component of the system and testing it, see if it works. The component being tested here is shopping list. It's not a whole program. It doesn't have like a menu where you do stuff, and it's just the shopping list that has basic functionality. So the unit test is written to test this unit of code. That's what the files are. The reason I provide this to you is because it is a way for you to check that your implementation is actually correct. That's what it's there for. All right, so I'm going to open all this up. I'm going to use Atom. I just think it works pretty good. You actually don't need cache. The other stuff you might want to look at. And then we'll wait a few minutes while this works. So one way to look at this is that it usually will tell you what you're supposed to work on. So in this case, you're supposed to, all the code you're going to write is going to go where? Shopping list.cpp. That's the one place you're going to write code. And your goal is to compile the unit test which will test your implementation and pass all the tests. That's your goal. I do that just because I believe that it makes life easier for people because you can sit there and work and test and fix and test and fix and test. And once you get rolling, you don't really need a whole lot of people interrupting you. You can just work. All right, so let's look at these things a little bit.
Declare the functions. And then write the logic.
Get bigger.
So we have a name.
That's the biggest it'll go.
Function.
All right, where am I at? Oh, Makefile. All right, so it's helpful to learn to read a Makefile and understand what the pieces are inside the Makefile. Is Makefile C++ programming?
No.
It is not. So that's the second time I've said it, so I'm just going to keep repeating it. But if you walk away and you can't answer that question, then you really weren't paying attention to that. Makefile is not C++ programming. It is there to manage a C++ project. That's what we're using it for. It's actually its own little separate scripting language. So that first line, and if you're an Atom, then you'll see the same colorings as I do. That first line kind of looks like what, though, in a program? No. At least to me,
Variable?
when I see a single equals, I immediately think of something.
Variable?
Variables. What I think of is assigning values to variables. So the variable is CPP flags. The value is that string of stuff. That's useful to know. The string of stuff, by the way, is switches that we're passing to a C++ compiler. We're using C++ 11 because that allows us to get some more modern features of the language that didn't exist before 2011 standard. The rest of those flags, the wall, wextra, werror, are to make your life more miserable, but also to get you in better habits as programmers. So werror means that everything that would have been, have you ever had a warning and it's still compiled? So that werror means that those warnings are now errors, which means it won't compile on warnings either. But that should then sort of instill in you better habits in programming as opposed to, well, compile, I don't really care about warnings. Now you gotta care, because it won't compile. Of course, you can always delete the werror out and let the warnings pass, but that's why it's there. The wall and wextra are asking the compiler to be an extra big jerk. So it's actually going to do some inspections on your code and actually gripe at you about some things that the compiler writers just think are bad practice. And then because the werror is on there, those things become errors as well.
Great.
We'll experience an example of that right off the bat. All right, so I'm on Windows, so I'm going to comment this. So here's a variable. I commented in for Windows. On these machines, right? Actually, this is going to work, isn't it? Yeah, I'm pretty sure it's going to work. And then I need to I know on these machines, I'm going to get the command console. So I'm going to comment in that variable. It's a Makefile variable.
Question. Yeah, I was trying to do this alone on my laptop. But it wasn't really working. So remind me how we fix the Makefile so it's not say case that the whole ship down.
To not do what?
To not say .txt.
Do you have the console?
Get the whole ship down.
So what I would do, because it's my preference, you don't have to do it. So you have two ways of doing it. One is that you change your system settings so that it always shows extensions, which makes like a hell of a lot. If you don't do it that way, then you have to go into the command prompt and rename it to the REN command. So REN space whatever its old name is, space whatever you want the new name to be. I don't know why they made that choice. I guess they thought it was confusing to people to see .txt in the file, but it makes programmers a lot of people.
REN space.
Whatever the old name is, which is probably Makefile.txt. Space, what you want the new name to be, which is the make file, with a capital N, and then the thing. All right, so last bits of the make file. You should know this. These sort of management utilities are pretty universal among programmers. Makefile is one of the classic ones. But whenever you get a project with a whole bunch of different files in it, you're usually going to have some sort of system that helps you manage all the compiling work around all those files. All right, so in Atom, the blue things are called targets. And I'm going to actually use a target right now. So I'm going to, some people may have forgotten this part, which is okay. I'm going to go back to my folder that has my files, and I'm going to click in the white space. Not on a file, but in the white space, off of all the files. And then I'm going to hold the shift key down. And while holding it down, I'm going to right click in the white space. And then I'm going to left click open command window here. At which point I can let the shift key off. I can let it off for a little bit. Now I can let the shift key go and I have the command window open. The reason I do that is because now I have the command terminal open in the folder where my files are. The command I'm about to use, I'll type it here. I'm going to use this command, w32-make, which is what we have to use in these machines. That's the command I'm about to type in part. And I'm actually going to do this. Clean. MGW32 clean. Yes. Make space clean. So nothing wrong happened, but we're just going to explore what it meant for me to plug in that word clean right there. So I'm going to go back to the make file. You see the word clean? So if we look at what happened, del star.o. So there's the star.o associated with the clean target, by the way. Where did del come from? What's this? It's the value of RM, which for me is del. So when I said make clean, it actually came down here, fetch the value of RM, del, space, star.o. This note is just Windows saying there aren't any .o files to delete. Yes?
So that was my problem. When I was at home, I was just opening up PowerShell on its own. So if you weren't to do it within the folder, how would
You're
you
going to have to learn to navigate in PowerShell.
Okay.
Which commands can do that? The CPU command change directories, which you should make yourself do. Just learn how to be a good operator.
So mine I have an RM down and right? But it's not really that high. I have a new Dell.
Well, why don't you have a Dell? Probably because you commented in this version. Would that be true? Then you commented in one of them. Then they'll say Dell.
Oh, you know what it is? It's you can save.
Yeah. What's the correct way to save an Atom? Control F. Those sort of basic key combinations are useful. All right, so how do I run? So clean is called the target, and I can specify that target, which is really just that command is the one that I want to execute right now. So how do I execute the clean all target? This one. No, I don't need to change anything in my make file. I want to execute this.
Make.clean.
Yes. So min GW 32 dash make space clean all, specify a different target. You'll come to like this, by the way, make once you learn how to use it. The alternative is just to memorize a whole bunch of long, terrible strings with compilers, as opposed to just sort of get it right once and then worry about it. By the way, did you notice that mine did Dell start on Dell before it did Dell start on UXD? No, but there's a clue, and here's the target. So why does your clean target run when the clean all target thing? Because I actually, I added it as this is called the dependencies. But basically, clean all, I told it, oh, and you also need to do clean, which it actually did first before it did itself.
So that's because it called clean and then it ran to clean and then it went to your other.
And then it did whatever the following command was. So I just sort of stacked those two commands. So the next one I'm going to do is shopping list.o. And what I would expect to see is the value of this variable followed by the value of that variable, which is all that crap, followed by this stuff. And this dash O part, by the way, means it's going to produce an output file called shopping list.o, which I'll see. So anyway, I'm going to MinGW32 make shopping list.o, which, if you'll notice, is only attempting to do compiling work on the shopping list code specifically. So there's my CC value. There's that CPP flags dash C shopping list.cpp dash O shopping list.o. And now if I go look at an atom, I can just see that there's a new file in here, shopping list.o, which means it's successfully compiled, sort of. At least it didn't find anything that broke the rules.
Can you add like style targets in the make file, or would you
You
be
could,
beneficial to have a separate?
No, you could. So you can make a target for style and have it run a command. That's all make really does, is if you give it a target, it runs the command. We can do it different. What's the last one to try? Unit test.exe. There's a trick you can use if you're used. So this is the first target in the file. If you don't put any targets, it's going to use the first target in the file. So I could say unit test.exe here, and it's going to run the command to that target unit test. It's going to have a whole bunch of errors. It shouldn't crash, it should just wall errors. And then I could also have run that target. So what targets it's going to run if I just say MinGW32-8? The unit test target, the first one by default. There's one other thing about this, by the way. So do it on shopping list.o again and see what the output looks like. This is the other little trick that this make system does. It did something different. Did you get that same thing as I did? It says it's up to date. Oh, you couldn't. So I remade the shopping list.o target and said it's up to date. So the other thing that make does is it keeps track of changes in your files. And if it doesn't need to run that command because no changes have been made since the last time, which is pretty neat.
Oh, you're right.
All right, so that's the make file. I could have just made you learn the commands. So there's no reason why you can't issue these commands manually. But I also just thought I could sort of take care of another problem, which is to get your customers to make problems. How many of you intend to go to a place like Cooper State? So some of the teachers there, when you submit projects, they just say the editing file. So you submit your project, and you make your make file, and they go into your folder and they type make, and better download it. Because that makes their life easy. They don't have to figure out what to do. You've already done that work for them in your make file. And then it either builds or doesn't build. But this is also one of the things you do if you're working at Google, right? That you cost Google billions of dollars if you fuck it up, but you get to the end of your day, you did a whole bunch of work. Before you leave, you say make, and hopefully all that work that you did compile. Because at Google, the entire company's code is in one repo. Entire company's code. You can fuck shit up royally if you want to. Now your make file is probably targeting your stuff specifically, and still you can still leave that stuff. It makes it easy for all their developers to access their entire code base. Except for a few, like the secret stuff. They've got lots of secret projects. Okay, so that's the make file part. That's if you want to know more about it, or if you still don't get it, then Google will help you find stuff that will explain make files to you more. There's tutorials on doing make files, there's examples of make files, I'm sure there's YouTube videos about make files. It's a pretty universal tool to program. And I'll separate you out from the Windows only programmers that can produce anything out of Visual Studio, which is true. Okay, so that's step one. I was going to do one more thing if you can sit it out for a couple more minutes. Make sure this is good. So when I run the default target, which is unittest.exe, the idea of this target, by the way, is that it compiles your code into the unit test code, and it produces an executable that you can then run to run the tests. So if I try to build that target now, I can't even compile it, which means I got to do something to get to a compiling state. So wall errors. Right from the wall errors. All right, so how do you go about this? What do you do next? What would you do next?
Find the first error and look it up.
All right, so one idea is to look at the .h file, which has specifications for functions that have to be implemented. The .cpp file, that's correct. All right, so I'll look at that and then make a decision about where to go next. So here's the .h file. So I wrote this, and then you implement the functions that are in it. What's all this stuff? Yeah, it's documentation that I wrote so that you know what your implementation is supposed to do. I'm using a style, by the way. This is called Doxygen style. So this at return, you can probably guess what I'm documenting specifically. Not the function. The meaning of the return value. So at return tells you what you get back when you call it. What about at param on the next one? It's describing the parameters. So the parameter index, all this documentation is saying is, what is that? It is an unsigned integer containing the zero-base index of the item. This one has two params. One's called new item. So it's just, I've written this here so that you understand what you're supposed to return and what the parameters you're receiving are supposed to be. All right, so here's the functions. There are 1, 2, 3, 4 of them. So what should I do? Start with the first one. Work on the first one. Okay, so one idea is to work on the first function in the list, which is probably the right thing to do. Is there an alternative to that?
Stub the function.
That's what I would do. So let's try that idea. So he said stub the functions. Does anyone know what that means?
No.
So what I usually endeavor to do is to get to a compiling state sooner than later. Meaning I want the code to compile.
Oh, so then it's gonna be like 70%?
Yeah,
Total return.
yeah, I'm gonna put dummy values inside. So I'm gonna stub the functions.
Also show me how to start functions with that phone number.
I'll be a two plenty on this. I'll wait for that.
Yeah, you can stop functions.
I was waiting for you guys to be done with your possibilities, so the rest of us should do stuff. I thought I talked about this, but maybe we didn't. So I'll restate it. If you're not gonna use for what we're saying and you'd rather talk amongst yourselves, please do that somewhere else. The next thing that happens is I kick you the fuck out of the class. That's the next thing that happens. Because there's 20 other people sitting in here, and you're not the most fucking important people in the world. So, but there, see how nice a guy I've become in my old age? Because what would happen is the first 5 minutes of class, you already get the fuck out. Because I'm being a nice guy, which the sad thing is, you raped me and everybody else because I did that. So sorry to everybody else that I didn't kick your ass over out. So anyway, we need to wait. Because if you're gonna go, it'll be a little disruptive. So we'll wait. Anyway, thanks for that. Thanks for listening and being. I think I even said something about the trees, et cetera, but anyway. Anyway, sorry to the humans. All right, so I'm going to stub these functions. Not everyone has heard of that, which is the reason why I wanted for them to not have to listen through other people talking while I do it. What I want to do, my goal is to get this to compile. That's my first goal. It's not going to pass the test, and it may even crash when I run the test, but I at least want to get it to a compiling state, and then I'll worry about fixing the function. Right. And one way to do that, the way to do that is to stub the functions. So I'm going to take this first one and show how to stub it. So I'm just going to copy the first line of the function, and then we go to the .cpp file, which is where you do the implementation. And then hopefully someone has done this and you recognize what I'm missing. Yeah. So this is called scope resolution. This is just an unfortunate fact about C++. If it doesn't remember where the get size function was declared unless you tell it. The get size function, remember C++, the one I declared in the shop in this class. All right, so stubbing, in this case, stubbing means that I have to return an unsigned integer value or it won't compile. So how do I do that? Actually, I want to stub it first. So stub it just means return anything that's legally an unsigned int.
Unit size equals 2.
Return 0 before it. Unsigned integers just mean they can't be negative. So this is not correct, but now it is stubbed and it should compile. I'm going to actually go back and rebuild it and just kind of eyeball the size of my wall of errors and see if it gets a little bit smaller. I can't tell. But my guess is probably, but I can't tell. All right, I'm still getting errors, so what do I do next?
Stub another one.
Stub another. So I'll go stub this one. make sure to resolve the function name to the class, not the return type, the function name, which is kind of easy in Atom because it should just all be blue like that. All right, what should I return here? Some of you are going to want to do this. This thing is not, strictly speaking, the same as this. This is a string object that I'm supposed to return. This is a string literal that's empty. So what I really want to return is a string object. If I leave these parentheses empty, it's an empty string. Or I could create the object and purposes say I want it to be empty of content. But that's pro tip. If you're stubbing a function like that or returning an empty off of it, it should be a string object, not just empty quotes, which is a string literal, not an object. Let's see what happens now. Yeah, doesn't matter. Or saving. Or yeah, save. Save before you recompile. Now this time, it is, but it's because it's complaining about something. And I can even see why it's doing it. Unused parameter index. And this part right here is saying, and that's because that's what you wanted me to do, is if there were a warning, I'm going to make it an error. So it actually is telling me it's giving me an error on the unused parameter index because I wanted it to do that. It would have passed by as a warning if I had not put this in my compiler. So I have an unused parameter index, which means to stub this function, I got to use the damn parameter. So I got to do something with this parameter right here. Here's what I usually do. Something like that. And then I put a note to myself that I did that while stubbing, so I got to delete that later. You got to do something with the parameter in the body of the function. Or the compiler will say, why do you have a parameter that you're not using? And you're not using it. Does everyone understand that?
Yes.
I'm going to recompile my wall of errors. I hope it's starting to shrink a little bit. It is. So now it fits on the screen. So now I'm making this about it. I'm going to go grab replace item. Grab it. Scope resolution. Try to do that first. At least I do, because I'll forget. First thing I do when I get it in here. So in this case, I've got two parameters to do something with and a return value. So I'll index plus plus like I did before. Make note to myself that I was stubbing when I did that. This new item, which is a string, I could just like make it empty. Note to myself that I was stubbing when I did that, and then return something that's a bool. I'll just say return false. True is fine. You can stub with any values that you want. Does everyone understand why I stubbed, why I did those two just sort of throwaway operations? Otherwise, I'll get an unused parameter error. One more. Oh, go ahead. I'm saving every time. Probably figured that out. I control S every time. And then I go back to the console and I use the arrow keys to recall that last make command. It should be a lot smaller this time, I hope. It's still the same slow every time. Now we're getting there. There's very little left. One more to stub, I think. Screen. Remember to return a string object for this stub, not just a string literal. At which point I think I might get a compile. So I'm gonna just remind you about this target. If I successfully compile, what comes out? Something does come out.
Fails.
The compiler page.
Yeah, but I mean, I get a result, I get a new file.
Or the .of file.
I actually get this. I get unit test.exe. So I actually get the test program will be there if I successfully compile. So I'm gonna make one more time. Now, one of the reasons why that's relatively easy once you get the code in place is because the make file has already put all the stuff together for you. And you just issue the command to get it to your Explorer. All right, so now it's compiled. I'm going to clear the screen. I have unit test.exe, which is how I then confirm if I'm passing the test or not. Unit test.exe, hit enter. So I actually somehow magically, without doing the damn thing, passed 3 of the 11 tests. I'm going to
Always
take
happens.
this out a little bit. I can scroll up
Let's
and
do
look at
that
all the
last
ones
semester.
that I
Just go
failed.
through and
If you want to see the ones that you passed, you can do this. Run it with -s. So unit test.exe space -s will actually show the passing ones as well. If I scroll up, I'll see some that I passed. All right, here's 2 up here that I passed. So the unit test is simply there to give you immediate feedback while you're working, so that you know if you're supposed to do right or not. I'm going to give you one more hint. I'm going to shut up because I was really long. I'm going to yell at people all the time. Right, so one more hint about unit tests. So if I see a fail like this, what I should do is sort of inspect that output and see if it will help me. So one thing it will tell me is where in the unit test code was this triggered. Unit test.cpp line 21 in this case. And it also tells me what it was trying to do when it failed. And then the last thing is it tells me on the left what my code produced and on the right what it wanted. So the left, see, nothing came out of my code, and what it wanted was, in this case, a bunch of commas. So you can use this output to sort of figure out what about the unit test broke my code. But there's an answer last question if there are any, otherwise I'll stop talking and that is your turn. Yeah.
So when it tells you a line 21, does that mean you want to look above that?
No, usually you can go on the unit test and you can actually go to that line. And sometimes your unit test will crash and it'll be the next line that probably crashed it. But usually it's in the unit test, it's that line or the next thing that came after it. Whereas in compiler errors, it usually is working way up. Yeah. Nope. I didn't really leave anything. The rest of this is writing code with standard STL arrays. So all the solutions are related to using STL arrays. This is also meant to be a review. It's got an array, it's got an if statement or two, it's got a for loop in it. Let me get hers. Okay.
So, I think this is my favorite make issue with my computer, but when I would use the main function make.
On yours, just use make.
Oh, really?
Yeah.
So
how do I
You'll
do
just
that?
type
How do I do that in PowerShell?
it.
Is that the same thing? Because I tried to write that out and it just tells me that.
So we have to set paths on your machines.
Oh.
So we need to figure out let's go look at where you installed an MGW and we'll fix your path. So kill the PowerShell because we're gonna have to restart it anyway.
How do I install MinGW?
Go onto the web and Google search
Oh,
MinGW.
okay, got it. And then it also said there was another file I had to download, so I just looked at that too. It said like in the file.
It should,
It said in the make file, I think. Yeah, it said right here, MinGW and MSYS.
oh, just do the MinGW.
Okay.
So I got two compiles of the, everything powerful. So when you're really cool, the stuff on the make file. So what it
What does it do? Try to take the O, see where it says -FO on line 14 in your make
Oh,
file.
the same.
Take the
You
O
can
off.
install this through command prompt.
Yeah. Just that, just that. Yeah, now you just save it. I'll try it like that. Oh, that's okay. That's just saying there are no .o files. It's just really ugly, no files to delete output. So I think I was trying to get, I thought the O option would turn off all that output. And it would just try it and not bother you if it failed to. Yeah, that's weird. Try it with the -S and see if it's actually doing some things and crashing. So space -S. Crashing. So it does the ones on line 18 and 19 successfully, and then it crashes probably on the one on line 20, or whatever's the next one after that. Okay. So what you want to go do is look and see what it's trying to do on line 20, and then ask yourself, why is that? Yeah, in the unit test. So go to the unit test on line 20. So I'm just sort of 18 work, 19 work, but it crashed. So I'm going to guess line 20, and then look at and ask yourself, is there something about line 20 that I'm not dealing with that was crashed? Is that loud? Well, how big is your array? Your array or the. So go to shoppinglist.h and find it. Well, think about that. It's an array of size 10. Okay, so it crashes because there's no 10. And it goes up to 9. Okay. So it means your code needs to deal with that. All right.
So now you can run, Okay, so kill this and let's go to pad 7. So first thing to do is hunt down where you install. Okay. So click on it and then click on solution. All right, now click in the address bar and copy that stuff. All right, now go to your search. Yeah. Yeah, type environment. You should get an option to edit a variable file. Yeah. And the array, you have to in this case, what you're going to do is append this to the end of the way out to the end of it. Yeah. Semicolon. Yeah. Right now,
downloadable.
Yeah, it's pretty big.
I mean, kind of. Like if you had like a computer from 1990, then this would be a lot of storage, but it's just a lot of little files. Like literally kilobytes in size.
Yeah. That's what the assembly says.
How did you guys get the unit test to pop up? Just type in unittest.exe.
Well, you're running on Mac, right?
Oh, it's good. I think there was this error here, but I don't know. So it's something like
No, I know.
Okay, that's okay. We may just need to, let's go look at that.
okay, so now I can just so if I do that.
No, it's okay. We're just, yes, it is. We're submitting. So there's a system where we're not closed down. Like, here's the trick. Close the PowerShell. It just works. Why is it seeing not work? This is what I've done before. So go back to search for environment. Yeah. Oh, yeah. All we want to do is
Download failed.
so just go back there, no, pop it up, look at it. Close it. Wow. So what are you, so you're just pulling it to, still not working. Yeah, but it's like, that's gonna iterate 8 times. Well, not this, this one. Yeah. Well, there's one other option out there. Are you an administrator user? Okay, then go back and install there. I still think you have it on the clipboard. So, where do you?
To include the.
I've seen this before.
Yeah, so whatever variable you, or whatever area you want, just add a dot.
I can start getting mad at it here. I got it.
Wait, where items is that like?
I'm really glad I actually remember some of this. Because it makes sense, but the really frustrating part is the test. Because we would get these things called coding assignments. I think that's what we call them. And we would have to, we would be given code, we'd have to test it. And it would be exactly like this, but a little bit structured differently. Like we would have Cloud9, you'd be able, it would already be set up for us, we wouldn't have to do it through CMD, but it would be exactly like what he's doing now. Like you would get fail, and then you change something, and like 9 of them work, and then you change one thing, and all of them fail.
Yeah, so it's similar to like a hacker rank or something.
Like the littlest things, but then you realize when you're writing the code, it's like something so simple. But then you have to figure it out, which is good.
Wow, I left out. I'm so confused that I've done this already. Yeah, you that's how it's true. Probably got and I literally just typed that in there.
How did you get
So
Oh, no, it's actually just unit test.
well, okay, so in theory, you want to
that
How do I get for him to run, like, say if I change it, how do I run?
It looks like it's in my file.
It looks like it's good.
Yeah, on here, but I'm.
So like close that, like, yes, and just retype it on the.
Yeah. And you do the. This should be what you, like, figure.
That's good.
I don't think so, it's not that.